Let me use just cash, kind of the easiest one to think about, to explain how the calculations would work. So let's look at the following example. Let's say the FRL department, or maybe it's just some company's name in general, right, decided to spend $5,000 to buy a brand new Xerox machine for its faculty, or maybe its employees, right, more generally. It is estimated to last 4 years. It will be necessary to immediately set aside $400 in cash as a buffer against unforeseen repair costs. This amount will be increasing by 50% each following year until the cash buffer is no longer needed by the end of the final year of the machine life. Calculate the change in net working capital for each year. So 1 year at a time, we need to see how the net working capital would be changing. And the net working capital in this problem is just cash. So only cash and nothing else. So you can think of everything else still being there, just not changing. So cash is the only part of net working capital that would be changing as part of this project. Okay, so it's a 4-year project, right? So we can imagine like a timeline with year 0, which is today, or when this project would begin, year 1, year 2, year 3, year 4. So if we immediately set aside $400 in cash, it means we immediately invest this amount of money. So the immediate net working capital that would be planned for this project is $400. That's money spent. What will be the net working capital, or think about the total cash reserve, cash buffer, right, as of end of year 1? So what do we know in this problem? This amount of cash will be increasing by 50% each year, right? So what is 50% more than $400 in year 0? We can calculate it by multiplying 400 by 150% of that, or by multiplying by 1.5, which gives $600. So as of end of year 1, we will have a total of $600 as our cash reserve. Then we do the same thing again. We increase this cash reserve by another 50%. So as of end of year 2, our cash reserve will be larger. What's 50% more than $600? We do $600 multiplied by 1.5, which is the same thing as 150%, and that gives $900. Then, end of year 3, same math applies. $900 multiplied by 1.5, which gives $1,350. So this is the total cash reserve as of end of year 3. And now we are moving to the last year, right? What does the problem say? The cash buffer is no longer needed by the end of the final year of the machine life. The final year is the 4th year. So if the cash buffer will be no longer needed, it means all the cash reserve that we would have by that time can go down to 0, right? $0. And this is exactly what we would need to put for the end of the final year. You can think of it as a rule. The net working capital at the very end of any project will always be equal to $0. However, this is not the answer to this problem, because the answer to the problem is calculating the change in net working capital for each year. So why is it important? What is the difference between net working capital and change in net working capital? So think of it this way. If I tell you that we invest $400 in cash right away for this project, then we invest another $600 after 1 year, and then another $900, and so on, that would actually be wrong, because during the first year, we do not invest additional $600. Out of the total $600 reserve, $400 are from the year before, right? So we would be double counting $400 if we say that during the first year we set aside additional $600. So how much do we set aside during the first year? Okay, so the immediate change is 400, kind of where we started, but then the additional or the incremental, so I'm now using the terminology from the beginning of this chapter, the incremental cash flow during the first year is $200. So $200 is actually the 50% increase, right? More generally, to find the change in net working capital for any year, you look at the difference in the net working capital between the year before and that year. So the difference between $400 in year 0 and $600 in year 1 is $200. And that's the change in net working capital over the first year. Now, the same way we can look at how much extra cash would be set aside during the second year. From the first row, where we have the total cash reserve, we need to see how this cash reserve would change. And we see that it would increase from $600 to $900. That's a 50% increase that was given, which in dollars equals $300. Then the same way we calculate the change in net working capital for the third year. So that's the difference between $900 in the net working capital in year 2 and $1,350 for end of year 3. That's $450. And now we go to the final year of this project. In the final year, things are again slightly different. Remember we said that the buffer will no longer be needed, right? So we recover the entire cash reserve that was set aside until the end, right? Kind of towards the end of the project. So there are actually a couple of ways to figure out what the change in net working capital is during the fourth year. Either the same way I did for all previous years, which would be the difference between $1,350 and 0, right? So that gives what? So what is, 0, the new number minus the old number, $1,350. It's $1,350, but kind of with the opposite sign, right? And actually I put the word recover here. So recover means that it's the opposite of investing, the opposite of setting aside extra cash. So rather than investing more, we sort of take it out of the project. We take it back. So it's a cash inflow for the firm, for us, and it's a so-called free cash flow that we can now put to use for anything else we like. Another way to calculate this final change in net working capital is to look at the sum of all changes in net working capital until the final year. So if you add up 400 plus 200 plus 300 plus 450, you would get 1,350. So either kind of look diagonally at net working capital for the previous year, right? Or look at sort of across same row, change in net working capital, and sum together, add up all the changes in net working capital that occurred in all previous years. Just to emphasize, all the changes in net working capital in this numerical example, all the way until the final year, are cash outflows to the firm, money that is invested. So you can put a negative sign in front of all of this, in front of $400, in front of $200, in front of $300, and in front of $450. But the amount that's recovered at the very end, which is the sum of all those cash outflows, is a cash inflow. So you can also put a plus sign in front of it, sort of to make it more clear, to make it clearer that it's the money that would be coming in. Okay, so this is, I would say, on the difficult side, like this type of net working capital information and how you sort of process it to get the incremental changes, right? The changes in net working capital. What would be other cases? So maybe we have the same problem. Oh, by the way, $5,000 was sort of irrelevant for what the question was asking. Kind of only there to confuse you. Let's say the problem is worded a little bit differently. It will be necessary to immediately set aside $400 in cash, and the amount will be increasing by 50% each following year, period. So if you remove the rest of the sentence, if there is no mentioning of recovering, the cash buffer at the end, what would it change? Actually, nothing. Everything would be the same. So you should always assume that the entire net working capital that was invested for any project would be recovered at the end, which means the total net working capital would be $0 at the end in the final year. Another variation of this problem would be, let's say we immediately set aside $400 in cash, period. No mention of how this would change. How would the timeline change? Well, if we set aside $400 right away, then it stays at $400, total $400 every year. So for the net working capital, we would have $400 in year 0, again $400 as of end of year 1, because there is no change, $400 again in year 2, another $400 in year 3, and as always, 0 in year 4. As for the changes in the net working capital, the immediate change is still $400, but then we would have $0, $0, $0, and in the final year, we would recover $400, right? That was set aside, a long time ago. So these are kind of the different variations of, how the net working capital could be given in capital budgeting problem. It could also say that there are not going to be any changes in the net working capital. Then you have sort of no dollar amounts at all. It's just all blank. Okay, so this was the third one of the 3 components of the total cash flow that needs to be calculated for every year of a proposed investment project. And so what were the 3 components? Operating cash flow, which is like profit from sales. Net capital spending, which is like buying all the big equipment items or buildings in year 0 and then selling them in the final year. And the change in net working capital, which, as you can see, is something that could be taking place every single year in our project.